For decades, climate scientists have studied the effects of climate change on Earth's systems. Climatologists closely monitor the effects of climate change on issues surrounding drought and fire. In this video, we will discuss the relationship between drought and fire and why Earth's climate system plays such a crucial role.
Climate change is more than just changes in the temperature, and in order to understand the ecological impacts of climate on fire, we must understand what climate really is. Climate is a complex process that is actually the long-term state of the atmosphere at any given location. So, unlike weather, climate looks at patterns and trends over time, and its equilibrium is imperative to understanding a lot of other Earth systems. As temperatures increase, other factors associated with plant, animal, and human life are also affected. Increased temperatures accompany climate change indicators such as reduced precipitation, decreased atmospheric stability, and changes in wind and water currents. Drought and fire are a dangerous combination, and understanding how these systems interact is important for better understanding the relationship between climate and fire. Droughts are just one of the many conditions that will worsen as we experience climate changes over the course of the next several hundred years. One of the effects of climate change is increased temperature. As temperatures increase globally, there will also be an intensification of the hydrological cycle, which is more commonly referred to as the water cycle. Evaporation will occur at a higher frequency, which will dry out the land as well as water systems. As moisture leaves the land and the water systems, droughts will become more frequent and more severe. Evaporation does not only occur in bodies of water, but occurs from plants, also called evapotranspiration, and from soil, which is known as soil water evaporation. Soil water evaporation is particularly dangerous in regards to wildfire. As soil moisture levels decrease, the physical and chemical changes that occur can change the rate of combustion and the dryness of fuel sources, which can increase fire intensity and frequency. As the climate change crisis continues, soil moisture levels will decrease and can stay low for extended periods of time, even years, after the fire. In November of 2016, North Carolina was continuing to see an extreme drought in the mountain regions. Unfortunately, a man-made fire caused wildfire to spread in one of the most devastating fire incidences the state's seen in a while. The images that you've seen and the footage that you've been watching have actually been images of the smoke in the areas from the wildfires. As you can see, the smoke is so heavy that there's no fire visible in the shots. However, you can see the smoke rising above the horizon for miles. Corey Davis works at the North Carolina State Climate Office and is providing us a little more insight about the impacts that droughts can have on fire and their frequencies.
So one thing that we often see when we get in a drought is that tends to lead to even drier conditions coming later. We saw this last year in the spring. Charlotte had one particularly dry month in May, and that led to, as we got into the summer, into June, July, and August, conditions just kept getting drier there because when you already don't have that much moisture in the vegetation and in the soil, then you don't get as much relative humidity, for instance, and especially in the summertime, that's one of the big drivers in precipitation, in the thunderstorm activity we get. So when you start off with drier conditions, then that tends to mean that you don't get as much precipitation, which leads to conditions getting even drier and drier. And often it takes one big drought buster event, like a big tropical storm coming through, to really alleviate that, because it really can be so tough to sort of overcome the dryness deficits that build up. One thing as we think about going into the future, especially as conditions will look different than they do now, is that we could see more of those severe droughts building up again, just because we would go maybe longer periods without getting regular rainfall. That could lead to, again, these cascading droughts where in one month we might have fine normal conditions. After a dry month, all of a sudden you could be in a drought that it takes half a year or more to get out of. And especially with temperatures being on the increase, that means you're going to have even more evaporative demand. It's going to sap that moisture from the soils, from the vegetation even faster, which would again cause those droughts maybe to be even a little bit more severe. Things won't burn, obviously, when it's wet, and if they do, then they'll just smolder, and smoke is obviously a big concern for things like air quality. On the other hand, if things have been too dry recently as well, that's not good burning conditions, because in that type of environment, things can quickly spread out of control, and a controlled burn can be an uncontrolled wildfire. So we expect the number of days that'll fit that perfect criteria for things like moisture are probably going to be more limited. So they're going to have to, I guess, be a little bit more smart about the days that they choose to burn. Now, fortunately, even though it looks like there will be those demands, there are actually some good, I guess, innovations, some good technological innovations that are going to be able to help them. Starting last June, North Carolina Forest Service was able to start using atmospheric dispersion modeling. Basically, that's taking the latest weather conditions and forecast and running essentially a burn, a smoke plume in that environment to show where the smoke might go. And they've had great results with it so far. They've been able to, on the days that they have burned, to burn more acres and more tonnage, really without any additional risk there. There have been a few cases where some smoke has been a concern, but for the most part, it's really helped them to be better informed in those cases. And certainly as the abilities of atmospheric modeling get even better in the future, we expect that that tool will again improve for them. So even in a world where they can't burn on as many days in a year, they can make the most of the days where they are able to burn. They can find the right windows and the right locations to do those burns. As far as wildfires go, again, this looking into the future is something that we expect may be an increasing concern. It's interesting if you look at some of the climate models, a lot of them are actually showing much of the East Coast, for instance, in North Carolina, getting a little bit wetter on average during the growing season, especially during the summer. But that doesn't really tell you the full picture about what conditions might be like, because what we expect to see is on the days when you do have rain, those rain events may be more intense and you may see more rainfall, but you may also go more days in between with no rainfall. And again, that's why we think that in the future, more severe, especially flash droughts that emerge pretty quickly, could be more of a concern. Again, with increasing temperatures, that increases the evaporation as well, which makes us think that drought could be more of a concern in the future. So obviously we think that would increase the wildfire risk going forward. Not only are you going to have potentially more fires because the environment is more susceptible to wildfire in the future, but also when you think about things like the wintertime temperatures could be warmer, that can mean that the time of the year when you see wildfires will grow. It could start earlier in the spring and extend to later in the fall in the future than what we have. Again, it's going to put more demand on groups like the Forest Service, on the Park Service, that respond to a lot of these events. But again, I'm hopeful that with some of the innovation that's coming around, especially with some of the computer modeling, that ultimately they'll be able to be better prepared for these events as well.
While no one wants to live in a situation of drought, we need to know what we can do to combat issues which arise with fire due to climate change. Some researchers agree that we must be proactive in managing fire and paying attention to the changing conditions of the soil and the atmosphere. Some of these recommendations include decreasing vulnerability by reducing surface fuels, creating climate-smart treatments which would allow for better control of fires in warmer climates, reducing crown fires by testing various methods of fuel treatments, developing a plan for fire as opposed to merely suppressing it, and managing realistic outcomes of unsuppressed fires with land managers, homeowners, and the community. Of course, naturally occurring or intensifying fires are an issue for fire managers, but they can create issues for ecosystems as well as human life. Understanding ways to burn wisely while showing concern for the environment as a whole is essential in part of understanding the relationship between fire ecology and climate change.